Hello everyone, welcome to the Game Engineering Podcast. Today I am joined by Toby, the lead programmer for Tin Hearts. Tin Hearts is a Lemmings-inspired puzzle game. In each level, you direct the toy soldiers towards their destination, but you can't control them. You need to manipulate the environment around them so that they can reach the destination on their own. Toby walks me through the complexity of various systems, including the pathing and time rewinding, which in turn caused custom systems for animation and required a suite of tools to even know what's going on. It was an amazing conversation. I had so much fun. I hope you enjoy it as well. So tell me about Tin Hearts. What is it?
So it's a narrative puzzle game where sort of inspired by Lemmings, but set in a Charles Dickens universe. You take on the role of a ghost of a toy maker, and you sort of live his life through various sort of flashbacks while guiding this troop of tin soldiers across rooms from a little box into a little door in the wall. But all sorts of stuff gets in your way. You got gaps, you've got like spiders that might eat them, you've got jack in the boxes that can come up and throw them in the air. It's sort of heavily inspired by Lemmings, but rather than controlling the little guys themselves, you sort of control the environment around them to sort of let them get where they want to go.
Yeah, and in Tin Hearts, there are a couple of moments when there's like aha moments, where you're like, ooh, this is so cool. So for everybody who's listening, this probably, there will be a lot of spoilers. So if you
Yeah,
want to play, want to play and get the cool aha moments, it's you need to proceed at your own care. Okay, and yeah. And not only not only do you control the environment, which is like the main part, right? At some point, you actually take control of the night itself.
yeah. Ultimately, you do get to actually be him and run around and sort of like, I guess, a Mario platformer where you sort of jump about, interact with stuff.
Yeah,
But we save that for like, I don't know, 3 or 4 hours into the game just to
yeah,
give you something to sort of unlock and keep it fresh.
yeah. This is one thing from technical point that was really interesting to me. Uh, if you design a game and if you make a game, you need to be aware that like you're designing around some constraints, right? So you have a constraint or you have a requirement that the game will be played and you'll be a ghost floating above the scene, so you'll see everything from a given perspective, and then at some point you just get down to and you're now controlling a knight and you're seeing everything from the little knight toy knight perspective, and everything changes. How does that influence the game systems and generally speaking like controls?
Well, it's kind of a stupid thing to do. Is you start off and you're building everything sort of relatively large scale. You don't need to worry about the little details because you're just a full-size person walking around. And then just we casually throw in the idea that you can become this, like, I don't know, 3-inch tall little guy that runs around. So suddenly you just need an insane amount more detail on all of the surfaces, and like you got to create little pathways they can walk along. And it our first, I guess, 20 odd levels before you get to this little guy you can control, uh, like their performance is kind of really good. There's not too many polygons, there's not too many objects in the scenes. It runs really well. And then you get him, and then there's just from that point on for the rest of the game there's just so many more things in every level. And it's not just the number of things that makes it difficult, because that obviously that that makes performance worse, and especially on platforms like the Nintendo Switch, it really struggles when you're pushing so much stuff through its CPU. It really struggles. But on top of the whole performance side of things, you've got like the cameras. When you're walking around as a big guy, the camera it's just where the player's head is. Like if you bump into a wall, you only need to bump into the wall. But when you go down into the little guy, every single tiny object on every table needs to be collidable so the camera can hit it and not go inside it. And it just meant like the amount of physics objects in the world that you can physically hit just skyrockets, and it it makes the computer very unhappy. It's yeah, it was quite a struggle for a while to get it performing well, and especially with VR when you're rendering everything twice and everything else on top. We spent maybe a full year optimizing stuff because it
Yeah.
just yeah, it
Let's
just
let's
didn't
just
run.
mention in the beginning what platforms Tin Hats are on.
So it we are on PC for Steam and GOG and Epic Games Store, and also the Windows Store for Xbox Game Pass.
Yeah.
Then we are on Xbox One and Xbox Series, then also PS4 and PS5 and Nintendo Switch, and then also for VR, we've got PC VR and PSVR 2 on the PS5. And we tried to do it all at once initially, um, and that was an awful lot of work and was getting a bit overwhelming. So we decided to sort of stop with the VR stuff fairly early on and focus on we've been calling it Pancake, where it's just flat on the screen. We've worked on that for a solid 2 years, just Pancake, to then get that finished and over the line, and then started introducing VR again. But it was quite interesting because when we around the time of release, there were 3 coders, um, and we all of us, it was our first job in industry working on Tin Hearts, and so none of us had any experience with handling the platforms.
Yeah.
Um, and we were suddenly releasing on, I think it was 6 or 7 platforms
Yeah.
on one day was the aim, which, which when you've not done it before is an insane thing to do, and I would not recommend anyone trying
Yeah,
to do it.
yeah. And also like you need to keep in mind that when you're playing and when you're developing a game, you're using your own like beefy computer to do this. And then if you're targeting also both generation like PS4 and PS5 consoles that are vastly different hardware, you can run into problems that are not easy, like not logical problems where you have an issue with the code and something doesn't happen. It's just that it's too much, and I'll figure out how to change this.
Yeah, well, all of our computers that we use to develop on are like proper high end,
Yeah,
proper like big gaming machines with really fast SSDs and like proper ray tracing graphics cards. And you get a bit complacent thinking, oh, this is going well, this runs well, and then you do your builds and you load it up, and then it crashes after like I don't know 10 seconds in a level, and you and then the worst thing about when it crashes on a platform is even if you figure out what it is, which in itself is hard on the platforms because you have to like remotely connect your graphics debugger or like the memory profiler to see how much RAM you're using or whatever. Even once you figure out what you think is the issue and you fix it, it's not an instant response. You have to then queue up a build, and it normally takes around an hour to do a build on our build system. And then you have to download it. And because we're all remote, we're just using our home internet, and my internet is pretty terrible. So it takes like 20-30 minutes to download the build. Then we've got to extract it for another 20 minutes, and then we install it for 10 minutes. And so by the time you're testing the tiny change you've made, it's been maybe 2 hours. And so you're sort of forgetting what you've done and what you were thinking you were going to iterate on, and you test it again, and it still crashes. And
Yeah.
it's just a vicious cycle. I spent the last 3 weeks trying to fix a bug on Xbox, and it's just that cycle of change like one line of code, wait 2 hours, test it, change another line
Yeah.
of code.
Are
It's
there are there some sort of emulators for you to speed up this? Like,
it's not really. You have Unity set up with whatever platform you're going
yeah,
to deploy to, but ultimately, if you want to know how the console's going to react, you just need to get a build over to it and
yeah,
see how it behaves. And there's no other way around it, and it just takes an awful lot of time. I know at larger studios they have like really great setups where they've got their their computers that do all of the building of the game are plugged into dev kits
yeah,
so that it just loads it straight on, and they have automated tests that run. So there's no people involved in the testing or the initial testing, let's say. But because we're quite a small studio, we and none of us had done automated testing before, and we didn't really have the time to learn it. So we just test everything by hand, and it yeah, it takes an awful lot of
yeah,
time.
yeah. And like when you're saying automated testing, it's also a different thing that people may from software engineering background may recall as automated testing. Like it's easier to have, for example, an HTTP server where you have like a tests that are running in memory quite quickly, pretty much in like milliseconds, and you just run them and make sure that if there's a parameter X, you react to this in a way Y. And here it's a little bit different because it's very difficult to recreate the state for all the things. So
Yeah,
you need to
we
just launch the game. And
yeah, well, you basically with automated tests in games, at least, like you can sort of hack it and write bits of code that will trigger X event and Y event to happen, and you see what happens. But really, the best way to do it is like record controller input. And so like if you're a character, you need to walk the character over to a place in the level, do something, walk somewhere else. But the problem is if a designer comes along and changes the level, you have to then re-record your test and then upload it and get it into the builds. And if you with us, we've got I think 63 separate level files in the game, and we had uh, whew, 3 designers at any given time touching various
changing.
levels, and they're only making small tweaks to each level, but then each one of those tweaks would then require a full test being created again. And I'm sure it would have saved us a lot of time in the long run if we had just set it up initially and done it. But I, we were always sort of like focusing on actually making the game rather than setting up
Yeah,
like a good testing infrastructure. So I think we suffered in the long run, but
yeah,
it's yeah.
yeah. The production aspects are brutal also for the game. Uh, yeah. Okay. Uh, so let's turn a little bit into more technical aspects, even more technical aspects of making Teen Hearts. First of all, do you have things that you're most proud of and you recall them like yeah,
I think we call this our biggest feature in the game, the soldiers walking around. We call it the pathing system
yeah,
internally because we sort of generate them a path to follow, and then they follow it. And we had to do this for all sorts of reasons, but basically we couldn't rely on the Unity physics engine to be deterministic enough
Yeah,
because we needed every soldier to follow the soldier in front and then you to be able to rewind them.
yeah, yeah.
Um,
So
and
just
when
to,
we
just to maybe paint the picture, right? You can imagine the Lemmings game and the soldiers. You're actually not directly interacting most of the time with the soldiers, so they need to. They're when they start moving, they're moving in front of them, just walking, and you can interact with the environment and change the path. But as a player, you'll need to see what is the path because you don't want to really wait for the soldier to get like changed, and then you need to revert things. So we have a incredibly sophisticated system for first showing the path and then interacting with it, and then as you mentioned there is a possibility to rewind time, so this needs to be react to time change as well. Yeah,
yeah, it's sort of like essential in the game. We had the original version didn't have this what would you call it, visualizer for what's gonna happen, and it makes the levels a lot harder to play because you sort of have to let the soldiers go where they're going and then rewind and then let them go again
yeah,
and rewind, and it really added a lot of friction to the gameplay. So we decide we decided to do this visualizer system and then didn't, I guess, really realize how much work it was going to be. Um, which we did build it on top of this pathing system that we created, but the whole pathing visualizer system itself took maybe, I want to say, a full year to create from start to finish. And we started experimenting because so you effectively you want to get a soldier from A to B, and there might be stuff in the way. And so the soldier or the path that the soldier follows needs to, say you're walking up to an angled block, which when the soldier hits the block, it needs to know that it needs to turn either left or right, depending on the angle, which is simple enough. You could do it with Unity physics and just shoot out a ray out the front of the soldier. It hits into the thing, and you go, oh, this angle's 45 degrees to the left. I'm going to turn left now. And it works. But the problem is if you then want the soldiers to be moving faster, you're going to have to be doing loads of these raycasts, which just uses up loads of CPU, but also Unity's physics system doesn't always give you the same result, which is really, really annoying. So some soldiers will go left and some soldiers will go right. And sometimes all of them will go left, but they won't turn left at the same time. And so they end up not following one another. They end up being all offset. And very quickly, your nice line of soldiers would just become they'd just be everywhere all over the level. And it just becomes impossible to play. So we needed to sort of work around the physics system. And so we ended up creating this system that when you load into the level, when you open the box, immediately before any of the soldiers come out, we calculate the path for, I believe at the moment we've got about 2 minutes of gameplay ahead of where the soldiers could walk. We generate in one go the second you open the box. And that we had a few ways of trying to do it. Initially, we had it where we just had from the box, it would shoot a single line forwards, see if it hits anything. If it hits something, should it turn left or right, or has it hit a machine that the soldiers might interact with? Does it need to send them into it? And that we worked on that for a bit. That sort of worked, and then we came to the realization pretty quickly that that didn't handle the sort of surface that the soldiers are walking along. So, like the tables are pretty flat, but sometimes they have to walk up a ramp, or sometimes there's gaps that they could fall down. And so you end up needing to check whether they're on top of something. So instead of just doing one long sort of cast forwards to see what they're going to hit, we instead take tiny steps forwards. So we do, it's about an inch at a time. We cast forwards and we cast down to see whether they're still touching the floor. And then we go forwards and down and see if they're still touching the floor. And just repeatedly doing that an inch at a time. And that then creates us this sort of like a bunch of path steps, I guess you could call them. And they're not going to necessarily be in a straight line anymore. They're going to be sort of like bumping up and down over objects as they go along. And then you get to an object that you hit and you say, right, turn right. So you put on a step there that says turn right. And then you rinse and repeat until you get to the like 2 minutes of gameplay. And we take these path steps that we've created and we construct them into sort of like a timeline, sort of I guess like a YouTube video where you can sort of scrub along it, pick whichever point you want, and all of the soldiers will know where on that path they need to be at that defined time.
And do you use, for the path steps, do you use like timestamp where they are supposed to be, or just like numbers that are just ordered path
Well,
steps?
we have time from the beginning of the. Well, it gets even more complicated. We split up these path steps that we generate. We then section them down into groups, and we call those segments. And so we have segments of the entire path that are made of path steps, and the segments are defined by a path change element, we call them, which happen at the start and the end of a segment. So say the soldier's going to walk forwards and hit into a block and turn left. The thing that they have hit has a script on it called a path change element, which lets the pathing system know that if it sees that, it needs to do something to react. So when it then says turn left or whatever, that is then a path change point, and so we cap that first segment of path off, and this segment then gets turned into a timeline, which all of the points along this segment they're given a time from the start of the segment.
Okay.
And so you can end up with hundreds of segments across a level, and then each path step is X number of. Well, we don't use seconds; we use milliseconds, and we store it as a long, so that it's incredibly precise, and it's using this fixed time system that is not using like. You wouldn't say this is 1.2 seconds along. It's like 1,600 along this segment is this point. But then on top of the moving the soldiers along these paths, we have to animate them. But the soldiers also need to animate the same when they go backwards. And Unity's animation system that they've got built in, it uses this whole sort of visual graph where you have, say, a walk animation, and then you have this big sort of, I guess, arrow to say turn left, and then you send the animation controller a request saying do a turn left now, and it will then start doing a turn left. But the problem is, if you then rewind, you need it to do the turn left at the same time but backwards. So rather than writing a bunch of code to make the Unity animation system do that, we embedded all of that into this pathing system.
Oh, okay.
So the timeline of where they're moving isn't just where they're moving, it's also what frame of animation they need to be showing at that position in space.
Okay.
And so we then don't use Unity's animation system. We use I guess it's part of the animation system. It's called playables, which lets us set the individual frame
Yeah.
at that point, and we can blend multiple animations together on top of each other, but it lets us set the individual frame at an individual time, which is quite nice because it means we can then go as fast as we want to any
Yeah.
point in the level, and they're guaranteed to have the correct
Yeah, this is
pose.
so cool. This is so nice.
It's it's nice now. It was not nice to make. It was a real headache to sort of think it through. But that also on top of this, and this is all still the same system that shows the visualizer.
So we
It
have yeah.
piggybacks on it.
So for now, like it shows the path, right? The visualize the path with this ghosty manner, and then it also is used for the moving. Like each soldier needs to interact with it so that it knows where it goes next, right? And every other object that is influencing this path needs to have the proper scripts and be able to react and tell you, okay, now I need to turn left, like you need to go
Yeah.
somewhere else. And then each path step of this segments, you have the frame of the animation. So now you're like blending at least like four different things into one.
Oh, there's even more. So we have these machines in the game where you for example, we have a balloon machine where the soldiers walk through it, and they get given a balloon, and then the
Yeah,
balloon means that they can jump over a gap. So this machine has a sort of trigger volume, which is like a box that if the path goes through this box, it it needs to know that it's gone through the box. We then have a thing living on this box called a path step provider, which intercepts the system that generates the path and says, stop doing that, have these steps and put them in. And so through this balloon machine, we hand give the steps that the soldier takes through it, and hand give the animation so they react to it and grab the balloon as they should. But also this balloon machine also gives game events. We call them game events, which the path needs to trigger when a soldier walks past them. So we've got this. So on top of the animation, the position, we've also got this thing that we call a game event track, which when a soldier goes past it, it will fire off a specific bit of code. So like give the soldier a balloon, or well, before you even get up onto that point, it needs to tell the balloon machine to start animating to
yeah,
prepare a balloon. And so that's then driven from the path system. But then those events also need to happen backwards when you rewind, so that it knows to play the give balloon animation backwards and take the balloon away.
yeah,
So that's the next level of complexity on it. Then so when you give a soldier a balloon, they need to know that when they jump off an edge, rather than falling to the floor and dying, they're gonna have like less gravity and they're gonna float through
yeah,
the air.
yeah,
And so we give these path steps, we call them a modifier. And so the modifier associated with the path step is a balloon. And so now the pathing generator system knows you've got a balloon. So if it detects, say, fall off of an edge, instead of falling, it will do a ballistic sort of trajectory calculation and put a bunch of path steps through the air
yeah,
to be wherever they're going to land. And then when they land, it will then remove the modifier of balloon, because there'll be a pop balloon event when you land. But then
yeah,
this all has to work backwards. So when they go backwards through the pop balloon event, their balloon needs to unpop and go back into their hand. They then play all of their animation from the jump going backwards. And then as they're approaching the balloon machine backwards, we have to then tell the balloon machine to start playing its give balloon animation backwards. When they
yeah.
get to the point halfway through, we take away their balloon and take away the modifier. And then yeah, it's
So, do I get this right? First of all, if you're doing a rewind mechanic, everything needs to be work needs to work twice, like in a
Yeah,
normal order and then in in the reverse order. But then you're saying the game events. So do you have, for example, game events and you have two game events, one for popping the balloon and one for popping the balloon when you go backwards?
yeah, exactly.
Okay.
We have a event, and an event is like a class
Yeah.
that is of type path timeline event. And in that, we've got the regular constructor of the class that you hand in all the variables that you need, the reference to the soldier, all that good stuff. But then we have a forwards game event and a backwards game event as methods in the class. And so then when it goes forwards, it runs the forwards one, and when it goes
Yeah.
backwards, it runs the backwards one. The balloon machine for that bit is quite simple. We've got other things that just go insane. We have events that queue up other events that just, it gets a bit insane with. So the spiders, for example, that are in the late game, we have these spiders that drop down from a spider's web on the ceiling and grab the soldiers.
Yeah.
Um, and so the soldier walks into an area where a spider can attack, but we've already calculated this before the soldier gets there on the path. So the path knows at this point I need to tell the spider web or the spider system that a soldier is now in the area available to attack. And so that then sends off a spider that moves across the web and drops down and grabs the soldier and takes it back up to its web and hangs it up somewhere. But the spider also needs to move backwards and forwards. So
Yeah.
we've then got the spider animation system actually runs an animation track the same as the pathing system's
Yeah.
animation track, and all of the events to do with the spider. So the spider, like, it crawls across the web to the right position, then it jumps down. So that's a separate event to say, spider, do your jump down. And then its visual effects on the spider will change and go red because it's in attack mode. So that's another event. And then it will attack the soldier. And so that's then an event on the soldier and on the spider at the same time, but they both need to go backwards at the same time, and neither of them can mess up massively, otherwise it breaks everything.
Yeah.
But then we made our lives even more difficult with the spiders because you have to be able to shoot the spiders with this power glove that you get. So you can shoot them with electricity and zap the spider and it explodes. But you can do that in the middle of the spider attacking. So we queue up all of these future game events of the spider doing the attack and the soldier getting killed and then getting dragged back up to the web. But if the spider's halfway through its attack and you zap it, we then need to clear all future events to
Yeah.
do with that spider, and then queue up the kill spider events so that the soldier can then walk through fine. But then
It's not a
if you rewind after you've killed the spider, we need to unkill the spider and then remove those spider future death events because you have no longer killed it because you've rewound past you killing
Yeah.
it. But then we also need to put back the original
Yeah.
future events for
Yeah.
killing the soldier.
Yeah. Yeah.
And so it it yeah, it it ends up breaking your brain a
How
bit. You
much
have to
how much time, roughly speaking, how much time have you spent on bugs with these systems?
honestly, I think probably about 2 years.
Yeah.
Is we about I want to say because we're still working on it now, and we released back in May, but we have the VR version coming out
Yeah.
soon. But the most, if not all, of the features and systems with the what the soldiers can interact with was finished probably around 2.5 years ago. And since then, we've just been trying to fix the bugs. For the longest time with the spiders, we had it that if you fast forwarded and rewound a bunch around them, they would just break. The spiders would stop attacking. They'd get in a weird state. They'd be halfway in midair, and they just stop working. And the issue that we were facing, or I was facing, because I did that code and I was bad because I did it badly. I was So when I queued up an event, and the event was you attack the spider, so the spider gets zapped and dies. The event that removes all of the future events of that spider attacking and queues up the die events. When I was removing all the future events, I was also removing the event that did that, which meant that when you rewound, it was then not giving back the soldier kill events because it deleted itself. But figuring out that that was what was happening took quite a while, because it was it was
But that's funny. Like you're saying that roughly speaking 2 years is now like first of all you need to create the system, and it's not like you know from the get-go how the system would look like. So like you learn by doing it, right?
But also the designers are designing new ways to use this system in the game, and so finding wonderful new ways of breaking it.
Yeah, so I would bet that after 2.5 years of doing and changing and modifying this system, you would be comfortable with writing the system from scratch in like 1 month now. Or 2 months.
For sure.
Yeah.
For sure. So many times I've wanted to just delete the whole system and rewrite it from scratch, but there's just so many other things that need doing that you just sort of have to accept that you can't, and there's no time for it. Even though you know deep down that if you rewrote the system, you probably would save yourself another 3 months of pain.
Yeah.
But it just, because of production and what is needed elsewhere in the game, you just don't get that luxury, and you sort of have to suck it up and just go, I'm going to deal with this horrendous system.
Yeah.
And it's not necessarily a poorly designed system. It's quite clever in how it works. It's just that you were designing it as you were making it. So and then you have to shoehorn in a new feature and a new thing that needs doing, and it just, everything stacks up on top of each other, and this system is suddenly doing things it wasn't designed to do.
Yeah.
So it gets a bit crazy.
Yeah. Did you have problems with soldiers or events going out of sync, or the segments with the time were enough to keep them in sync?
Well, yeah. Initially, we were using this asset store plugin called Kronos, which would handle the rewinding and fast forwarding positions of objects, and you could queue up events to it. But that system got out of sync with our own system, so that system would be firing off game events, because we initially had it so that the soldiers lived on the pathing system, but anything that wasn't the soldiers, that was just in the world, lived in Kronos, because it was just so easy. It was just an object. It was just a script that you drag onto it, and suddenly it rewound, and it felt amazing. But it would get out of sync. But we still use this system for some things because it's really good at what it does. But we had to hack a bunch of it to make it sort of as in sync as possible with our system. But because currently our pathing system, which is also the fast forward and rewind system, which is also like the event system, it's basically in each level there is one pathing system which every single event for every single object gets put on ultimately, and they are just in a list of their long time of when they fire, and because they've been put in, you're always going to have this one happen after this one, and it works. But then sometimes you have it where you fast forward, and within one frame, say 10 events could happen. And so we have to make sure that we do all of the events in the correct order, otherwise things will mess up. And then the same backwards, but it's quite nice because they've all been queued up in the right order, so they they will stay in the right order until you rewind back past it. But you then have to remember that when you rewind past an event, anything that that event has done needs to undo itself. And so sometimes a game event will set up other game events, like in the case of the spider. So you need to make sure you delete every single one of them. But then also, if you've got any, like, say, what do you call them, actions or events that you've subscribed to, you need to make sure that you unsubscribe those things, and you just have to make sure that you've done everything that you've done the first time round, but do it backwards. And it makes sense, but when you're sat there doing it, you always forget one thing.
Yeah. And debugging this, how have you had like automated tools for this system, or
So we've got sort of like a on the pathing setup, pathing system object. We've got this whole, you can see every single event that is on it at any time, so you can pause in the editor and you can see every event that's there, and then you can watch it as you rewind, and you can see which ones get removed at which time and which ones are still there. And then you can
let me stop you just for the listeners. In the Unity and pretty much other game engines as well, you can play the game. So you compile your code, you play the game, and you see the results, and it's happening just like you would play the game. But then you can pause it, and you have, generally speaking, two windows. One is for the play from the camera, how your player would see it, and one is the editor, where you can move around freely and you have additional information. So you can have it both during the play, you can stop and inspect every little detail about the object that is in the scene, and have additional gizmos on the scene displaying what's happening. So like you have more tools than like during the game when you play it.
You can give yourself like information overload about everything. You can just, if you want to know anything about anything, you can click it and it'll show it on your screen. And if you're clicked onto something that, say, is, I don't know, moving whilst you're playing, your computer will die. It's updating the values that you're seeing so fast that the game starts running at 5 frames a second, and then Unity will crash.
But you were saying when I interrupted you that you had for the pathing system, you had all sorts of gizmos and events that you could just visibly see what will happen.
So we have a big list of, so on the pathing system for just the events, we have a event timeline, I believe it's called, which is just like a drop down list. Effectively, you click it and it just expands, and most of the time there's, I don't know, 200 events on it. And so you then have to scroll down, find the one that you want. You can then expand that out, and then you can see all the information about that single event, including the script that it lives on, the trigger that caused that event to be queued up. See all the information, and then you can click on it and it will even open the code file where the event is coded, so you can see the code for it. It's quite nice. It took us quite a while to realize that we needed that. So we've been living without it for quite a while. That's just for the events. We have the same thing for the segments that the soldiers move along. And so because the events are sometimes on segments, but sometimes, in the case of, say, the spider, the events are only associated with the spider and not a specific point on the path. So some events are just events that live on the event timeline. Some are events that live on a segment. So to get to those ones, you have to expand and you see all the segments, and you normally have, by the end of a regular level, if a regular person's been playing and they've tried a few different things and maybe not done the perfect route, you're going to have, I don't know, 300 segments maybe, depending on the level. And so you then go through all your segments, and then you expand it, and you can see we have 3 tracks. So we have the animation track, we have the game event track, and we have the path step track. And so you can, on the animation track, you can see at what point along the segment each animation starts and ends. On the game event track, you can see which specific event is queued up at which point. And then on the path step one, you can see each path step, and you can see all of the information about a path step. So whether they're holding a balloon at that point, whether they are, what position they are, whether they're going down a hill, up a hill. You've got whether that path step has been affected by a path change element, which is the blocks at the end of the paths. But this is still not as complicated as it gets.
Let me mention before we get there. Hold that thought, because this is also might not be obvious. That you're now saying and describing a custom tools that you've and custom windows within the editor that you added to handle this, because this is like a hidden work for all the players. Usually players have no idea. Like you get let's say your Unity editor up, but for your game you create systems that are complex enough that you need additional tools within the editor to both handle it, to both create it in terms of like designer, changing things. So you're now saying about timelines that are not like a Unity built-in stuff. There are custom tool windows that you need to create first and make sure they work. Like it's a hidden thing.
You're debugging your own tools that are letting you debug your own system.
Yeah.
And then the tools, the problem is you're confined to what Unity gives you with how your tools can look and what you show. And so you might have this wonderful idea of how it's going to look, but then you're limited to a bunch of drop-down boxes and just like plain text. Like you can give it a bit of color, but you can't really make it that nice. You can't necessarily view it on a timeline. You end up just viewing it as a list with a bunch of numbers next to it. So it's not the nicest thing to look at.
Yeah. At this point, have you wondered like next game I'm gonna do with my own engine, because I feel like I'm rewriting half of the tools, or not really?
It's a weird one. It goes in waves as you think, oh, I hate Unity. Why isn't it easier? I'll just do it myself. But then you look at the bigger picture, and Unity just handles so much of it for you. And it's frustrating. And they bring out an update that fixes things, but you're on a different version of Unity and you can't upgrade. And you think, well, if I made it myself, I could just fix it and it would work. But Unity handles so much of the stuff for you that I wouldn't want to move away from an engine like either Unity or Unreal, because they do so much for you. I couldn't imagine writing the engine on top of writing the game.
Yeah, that's a lot. It's a lot.
And I guess with the big companies, they've got hundreds of people that are making their own engine.
Yeah, and also all the big companies are anyway switching to Unreal now. So it's like it goes to tell how much of this is actually, like, how much work this is.
Yeah, it's
and quick note on versioning. Like, again, if you're coming from software engineering background, you might feel like that, we got semantic versioning, so you can know that there are changes that will not break your editor, so you can update it. It's like, no, it doesn't work this way. If you start a game and you select a version, you're bound. You're bound with this version.
Well, we had that issue because Tin Hearts has been going for nearly, I may have this wrong, I think 8 years now.
What?
Since the inception. I'm pretty sure it was 2018, 2019, 2020, 21, 22, 23. Maybe only 6 years. Okay. Still an awfully long time.
Yeah.
But then so back then, the version of Unity that it was started on, I believe, was the 2017 version of Unity. We're now using the 2021 version of Unity.
Yeah.
The 2017 version of Unity, we just couldn't use it because the platforms don't let you release using that version of Unity anymore. So, and it doesn't support the new platforms that have come out since 2017. So you're sort of in a constant fight of like, oh, do we upgrade? But when you then upgrade, half your game breaks. Like any shaders that you've written for like camera effects or whatever, that's going to break. Your lighting setup, probably going to break. Your camera system, if you've used Unity's camera plugin Cinemachine, that's definitely going to break because they've improved it and completely changed how it works. So you've got to weigh up like the benefits of upgrading Unity version to the how many months of work you're going to have to do to fix everything that breaks. Sometimes you're lucky and it doesn't break too much, but normally you end up with lots of stuff sort of just falling over and having to just pick up the pieces, and it just it's a lot of work.
And tell me maybe a little bit more about the VR version of the game, because that's as you mentioned before, Tin Hearts, or usually when you're making a VR game, you can have like a game that is set to run on PCs. At some point you freeze this and then you create like a separate project, or you just make this project into a thing that will work on VR, but now only on VR. You're just happy to rip apart every other system that is just bound to PC, right? This is what's called port. And you port a game, that's pretty much what you do. So you can have the same project open up and work on both systems. And you're trying to do this with Teen Hearts, or you have done this, so that the game works both. The same project works both.
It's the same executable.
Yeah.
It's so you launch tinhearts.exe and it will run in flat mode, and you launch tinhearts.exe with an argument that says -VR mode, and it works in VR. It's the same level files, same literally the same objects with the same scripts on them. So every object, say for example the prism block, because it's the simplest object. That one, not only in Pancake, I'll call it, just you look at it, you click your mouse button, you pick it up, you can fly it around the room in sort of like a third person control, plop it down, unclick it, and it stays where it is. You then also need to have it so that you can physically pick it up with your VR controller in the hands. You need to pose nicely around it, and your fingers need to not clip through it, and then you need to be able to lift it up. And then we hate ourselves, so we added a system where if you let go of it in midair, it will float in like a zero-G way for a couple seconds, and you can grab it with the other hand. And so that's a whole system. It lives on the same block that is also being used on the flat version. But both of these systems of movement need to then hook into the pathing system and everything. So we've got we're talking to the same script saying this block has now been moved, update the pathing system. And it's quite a bit of work. And then like any shaders that you do, so we've got ghosts in the game. The shader for the ghosts, it worked brilliantly for flat. You could see through them. They looked fine. They looked like they were where they were. It was all good. You put on a VR headset, only renders in the left eye. And then spend a bit of time working on it. It renders in the left eye correct, but in the right eye, they're upside down. And it gives you a headache playing it, but you've got to try and figure out what's wrong. And then you fix them being upside down, but then suddenly you can see them with the left eye fine, but in the right eye, you can only see them if they're on the other side of a wall. And then if they're not on the other side of the wall, you can't see them in the right eye. And graphics programming is so complicated. And it melts your brain, because in VR, you sort of, you're doing everything twice, but you need to make sure you haven't messed anything up the first time so that it can then do it the second time.
This one, can you tell me a little bit more about this? Because what changes when you're from the, let's say, normal 3D development when you're making things for VR?
So, like, for the most part, if you don't write a custom shader,
yeah,
you're probably fine. Unity just handles it. It's all good. But you've got, rather than having one camera for one screen, you've got two cameras, one for each eye, so you're rendering everything twice. And there's two ways of doing this. There is a thing called single pass, where it will render both eyes at the same time, and it will treat it as one camera, but it's not. It's two cameras, but it does some clever stuff to sort of do it at the same time. Or you have something called multipass, which is where it renders one eye and then it renders the other eye, sort of one after the other, which is how we have it working in Tin Hearts. There are reasons for choosing one way or the other, and we just settled on multipass because it worked for us.
what are the reasons?
It's some shaders and some things are just more efficient to do in one go, because say you've got a post-processing effect or
Yeah,
I don't know, you're changing the color of everything,
yeah,
applying like a color sort of filter. Doing that once, you're just saying to the graphics card, do this job on this image, and it just does it once. Whereas with multipass, you're doing it twice, and the images are smaller, but you're doing it twice. There are other reasons I don't understand
okay, okay,
that are more complicated. But for us, multipass seemed to make the most
yeah,
sense.
work better,
But
yeah,
the problem with our ghosts, which is also the same shader that is used for your hands, because the hands in the game are transparent,
yeah,
so you can sort of see through them. And transparent things are horrible.
yeah,
Um, but in order to do that, you have to use this thing called the depth texture, which is when the camera renders the image after it's drawn or when it draws an object, say a table. Not only does it draw the table's pixels to the screen, it's then on a separate, call it a file, it's a buffer on the
yeah,
graphics card. It will draw a gray image where white is closest to the camera and black is furthest away from the camera. And so we then use, for every single object it draws this. And so for the it uses it to know whether the object it's drawing is in front or behind something else, so whether it should actually draw the pixel to the screen. So we then need to use this for the ghosts, because we need to know not only what's behind it, but also if there's anything in front of it, because if there's something in front of a ghost, we shouldn't put a ghost there, because you want to see the thing that's in front of it. So we've got to sample the depth texture and go, is the ghost's position in space, or is the ghost's distance from the camera closer or further away than this point on the depth texture? And if it's closer, then you draw a ghost there. But we did a weird thing that ultimately ended up clearing the depth texture after it finished doing all the ghost processing the first time, and so then there was no depth texture for the other eye, which got us really weird results, because then you were seeing the ghost correctly behind things in your left eye, but in your right eye it was in front of everything.
this must have been super creepy though. Like,
I see.
what happens if you have both eyes open in VR and one eye sees the exact the same scene, but with the ghost, and the other doesn't, and then they'll switch, and it's like,
It gives you a massive headache. It's horrible, because your brain isn't used to seeing, because it's in the correct place,
yes,
3D as well. So it it just messes with your head and it hurts. It's yeah, because we had a very similar issue with the outline that we have on objects. So when you point at an object, it draws an outline around it, like a
yeah,
blue
yeah,
sort of fuzzy line. But we had that so that you could see it in your left eye, but on your right eye it was just in a different position, but the same shape and correct in 3D, just in the wrong place. And so we had at one point where you could see a ghost in your left eye, but not in your right eye. And then you had these outlines that were showing in both eyes, but were wrong in one eye. And the problem, it, uh,
Yeah.
it really made your head hurt if you stayed
Yeah.
in it too long. But you have to go in to see whether you've fixed it and to sort of see the behavior. And
And
uh,
getting back to the platforms and testing on platforms, there is no other way to test VR than just
well,
putting the VR headset.
yes, well, you could hold the VR headset.
Yeah.
Unity does have a built-in virtual headset that you can
Okay.
use, but you have to then manually move it in editor to the place that you want, and sometimes it works and sometimes it doesn't because
Yeah.
of our setup. Because it's such a long project, the setup wasn't initially set up to be able to use it, and then we've
Yeah.
changed it, and it didn't ever work great for us. But I'm sure other people use it all the time, and I'm very jealous of them because I just sit there and I tend not to put the headset on anymore. I use my thumb to cover the face detector so that it will turn the headset on and start tracking. I just hold it up next to me, and I hold a controller in my other hand, and I just sort of watch on my screen and try and get it into the right place. Which it's an awkward way to play, but at least I don't have to put the headset on my head.
Yeah.
But you still have the faff of you press play, then you realize your headset isn't turned on, and so you quit, you turn it on. And because we use the Quest headsets nowadays,
Yeah.
um, they're not. It's not just like an HDMI cable plugging into your PC. It goes over USB or over the Wi-Fi, and so it loses connection when you're not using it. And so you turn it back on. You got to then navigate in the Quest to say connect to the PC. You wait for it to connect and boot up. Then you have to hit play. Because the problem is if you hit play before the headset's connected, it just won't work. And the Unity project's so big that it can sometimes take like 5 minutes to get into play mode.
What?
Um, oh yeah, our Unity project is insane. The game itself, when it's built, is only 12 gigabytes.
Yeah.
But the Unity project itself on the Git project that you just download from Git before
Yeah.
you've imported anything is around, I believe, 300 or 400 gigabytes at the moment. But then
Okay.
when you open it, it does all the imports into the library file
Yeah.
in Unity, and I don't really know what it's storing there, but it has to do it. It takes around 2 hours to open the project the first time once
Yeah.
you've downloaded it. And then it's taking up like 600 gig on your disk. And so if your disk isn't particularly fast and stuff has changed, when you hit play, it takes ages to start up. I've been quite lucky and don't have it happen too often, but sometimes it was just taking forever to even just get into it.
How
It's,
big? How big? And which types of SSD do you have in your computers?
I mean, it's well, it's mainly the art assets and all the
Yeah. 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 Yeah.
pictures
Yeah.
and
But
stuff.
still, how big SSD disks do you have?
Oh, I can check right now. It's insane. It is
Because, like,
absolutely
if
insane.
you have a
I have got
600 gigabytes project, and depending
one,
on, let's say you want to copy it,
9, 10, 11, 12, 13, 14, 15 terabytes
what?
on my
Okay.
PC, and I pretty much all of my drives are full because I have to have a minimum of 7 copies of the
Yeah,
project.
yeah, yeah. This is what I,
Because
yeah,
and I've read online that you can do this thing where you switch the library file, and so you don't have to have a duplicate of the project. But every time
okay.
I've tried that, it's just messed it up for me. So
Yeah, yeah,
I keep 7 copies.
yeah,
But then you have the whole faff of if you're not working on, say, PlayStation 4 for a while, you got to remember to keep the Git updated and keep opening the project, because
yeah,
otherwise, next time you go to it, you've got an hour of importing because there's been so many changes.
yeah,
It's
yeah, yeah.
yeah,
Yeah, and underneath, I'm guessing you're using Git LFC, so a large file support, right?
yeah,
Because Git itself is, I think, has a cap for 2 gigabytes for because it's meant to
yeah,
store source code,
yeah.
not game assets.
It's most I maybe most. I'm not entirely sure if it's most. probably is. Most game devs use either a thing called Subversion,
Yeah.
which is like
SVN.
it really, really old
Yeah.
version control stuff, or they use Perforce
Yes.
because it handles these large sort of
Yeah. Yeah.
um,
Yeah.
level files and art files much better.
Yeah.
But we use Git because we most of the maybe not most of the company, but at the moment there's 5 coders at the company, and our creative managing director was also a coder. So
Yeah.
we like Git, we know how it works, we
Yeah.
like
Yeah.
creating branches and merging and all that stuff, like because that's how you do code good.
Yeah. 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 Yeah.
So we like that, but lots of other studios use Perforce because it means you you're not necessarily dealing with so many large files on LFS. Because this is the other thing, we can't host Git using, say, GitHub or GitLab and
Yeah.
their enterprise solutions because they only let you have 50 gigabytes
Yeah.
of
Yeah. Yeah.
storage. If we contain all of our history of the Git project, it's probably talking about over a terabyte. Like
Yeah.
just the project and all its history and all its changes.
Yeah.
It's a bit nuts.
It's again a point for like why game dev industry is pushing the development of new tools and new things in general, like compared to other industries. Like game dev industry runs into problems much earlier than the rest part of the coding world, at least because of the things
Yeah.
like that.
Because if it was just our code for the project, like yeah,
Yeah.
we've got tons of code, but I don't think it rivals anything that some of the
No,
big
no,
like banks are using in their Git projects or anything. But it's throwing in all of the textures, because when you're making a game, like for the PC, you want the textures to be the biggest possible, and like even for PC, we crunch them down in the build because when the game is built and uploaded to the stores, it's 12 gigabytes.
yeah.
And on the Switch, it's only like 5 or 6 gigabytes. So it's just insane that it goes from like a
Yeah.
300 gigabyte project for all the assets and stuff down to 12
Yeah.
when it's done. And sure, we're not great at not keeping stuff in our project when we're not necessarily using it. There's a lot of stuff in our Unity project that
Oh yeah, but that's also difficult.
yeah, well,
And like engine itself, editor, is not really helping with it, with like, trying
oh,
to hint you. Like it's just there. So like
it
you have
doesn't
no
tell you what
idea.
you're using or what you're
Yeah,
not using. So
yeah,
you have to then write a tool that
yeah,
tells you what you're using and what you're not
yeah.
using, which we have written one that goes through every single level in the game, but only the levels that are like actually in the published game, because we've
Yeah,
got tons of development
yeah,
levels that we use for testing. So we select all the levels that are in the game, and we run the tool, and it tells us everything that we're using and everything that we're not using. But then you don't want to delete something if you think you might use it in future. And some
yeah,
like we rely sometimes on like what do you call it, asset store plugins
yeah,
that other people have made, and we've just downloaded and brought into the project. Um, and so we don't really necessarily want to delete a bunch of stuff from that because we don't want to break the plugin, and because we haven't coded it, we don't know what files and things it's relying on, so we just sort of leave it all there. And like if we had the time, we could dig into it and see which ones are fine to delete and which ones aren't, but
yeah, yeah.
you
But
just
that,
sort of run out of time.
yeah, yeah, yeah. Like time is not the resource you have plenty of. Like you're very constrained on time, so it's not like,
Yeah,
yeah, I spend a week trying to figure out and like I design a new system for marking our files whether we want them or not. Like
yeah.
that's not gonna happen.
You can buy another hard drive.
Yeah, yeah,
It's-
yeah.
yeah.
Can we get back to the ghost rendering, because I'm actually interested in the shader part. So
Yes.
when when we're talking about shaders, what usually mean is that like in the rendering pipeline you have a moment which is usually called like fragment shader, where you can do all sorts of tricks based on like 2D visualization of a 3D object, right? So you have a 3D person and you want to make it ghost-like. So you want to change the actual pixels and change the color of them to be a transparent. So for example, like a blend between the color, for example, let's say ghosty blue color, and the thing that is behind. But to actually create a shader, and this shader will be run. This is for me, it's mind blowing still. Like that the shader will be the same code ran for different kind of pixels, and
Yeah.
you need to do this mental shift that it's gonna be like it needs to react well, even if it starts in this pixel and this pixel and this pixel. It needs to be the same code for everything. So first of all, writing shaders is not
Writing
particularly.
shaders is, it, yeah, it takes a long time to get your head around it.
Yeah.
Cause I'm not a graphics programmer myself. I'm not trained or anything. I haven't really done it, but because there's only, well, at the time there was, I think, 4 coders at the company. 2 of us touched this, and it it's been rewritten like 3 or 4 times to
Yeah.
change things in it. The original version is still there underneath everything, but basically the way it works is so in Unity you have the concept of layers for objects. So when you drag stuff into the level, you can say this object is on this layer, and so we use some of the layers for, say, physics objects. We use some of them for we use a bit of the layers for lighting. We use some of it to say the soldiers can interact with only objects on this layer,
And
but
it's
not
like
on other ones.
it's like a category, right? Like it's
Yeah,
not
it's
really
like
a layer.
categorizing
Yeah.
your
Yeah.
objects. So we categorize all of these ghost objects, which are the objects that are rendered by the ghost system, and then which means the camera does not render them. So when the game camera renders the scene, there's no ghosty things there. There's just empty. Well, there's just whatever's behind the ghost, because the camera just doesn't know about them. We then, on all of these ghost objects that are on the ghost layer, we also have a script called a ghost object behavior, which on that we store how transparent they are, and whether they should listen to the global ghost transparency. So some ghosts can fade in and out as they want, and some of them get controlled by this global ghostiness that like controls a bunch of them at once. So for example, like a cutscene, you want all of the characters to fade in and out at the same time sometimes, so you make them listen to the full transparency rather than their own one. But we then take that, we then have this, Unity has this thing called the scriptable render pipeline, which is, it basically just lets you add extra, they're called passes onto it. So basically after Unity is done doing its stuff, you can then do your own stuff that you've coded yourself. So we have these render passes for ghosts, and you can select when in the render process they happen. So you can have after solid objects, before solid objects. You can have before transparent, after transparent, and then I believe there's before UI. I'm not sure if that's still a thing, but we do ours after transparent. So after it's done all of the solid objects and all of the transparent objects, our render pass happens. So what gets fed in is the what the camera has rendered so far, which is a room with everything there other than the ghosts. And then we have fed into this render pass a list of all of the objects that have the ghost object behavior on them, which gives us just a list of like meshes to draw. We then draw them just regularly onto a separate like image that is just the ghosts, but they look normal and solid.
Okay.
We then pass that to we then basically copy that to another texture file, but we cut out all of the bits that are behind stuff with the depth texture, and then we also make it transparent based off of how transparent that specific ghost should be. So that one then sits on the ghost output, and then for all of the other ghosts, we do the same thing because they can have a unique amount of transparency. So we have to render them separately, and then we copy them all onto this main final ghost
Texture. Yeah.
Then we run a blur pass. Well, then we draw that ghost texture a second time behind it, or on a separate file. We then make it, well, in the ghost case, we make it blue, I believe blue or white, just basically like a silhouette of the ghosts. We then apply a blur to it using a blur filter bit of code that we found online somewhere that some smart person wrote, to make it sort of blurry, which sort of gives them a glowy effect in the background. So they sort of, the ghostiness, you feel like it makes it a bit more ghosty because they've got soft edges rather than a hard edge. So we then do that. We then make that also transparent. We render that. We take the new ghost, so the transparent ghost without the outline, and we subtract it from the silhouette that has been blurred, which then creates the outline but is not drawing a big white box behind the actual ghost. So you end up with a ghost with a blurry outline around the edge of them. We then stick those two together, and then we draw that then on top of the rest of the game.
Okay.
So the fragment and vertex shader thing you spoke about earlier, we don't actually use for the ghosts because we render them normally. Because in a fragment shader, which is the code that lives on the material that is on the actual object, that object doesn't know what's behind it. So if you don't draw that pixel, it would just be black.
Okay. Isn't okay. For some reason I thought that there is a possibility to kind of interact with what's behind when you make a...
So if you mark it as a transparent object, it will handle that, because transparent objects don't draw to the depth texture, which is the thing that then tells Unity to not render what's behind it. But if you're doing extra stuff to it anyway, transparent objects are kind of expensive because you're rendering the stuff behind them and then the stuff in front of them, and it itself. So for us, we were better off doing it separately, because also with a transparent object, so you could see it. So if, say, you've got a person and they put their arm behind their back, with a regular transparent object, you would be able to, so you'd see through, so you'd see the ghost, but then you would also see their own arm behind them. Which in some games maybe it makes sense, but in our game, because the idea of the ghosts are sort of memories, we wanted it to sort of almost be like a film is being projected, sort of like it's a memory. So you're not going to remember seeing someone's arm through their back. So we render it as a separate thing solidly, so you don't see their arm behind their back, and then make it transparent.
So if you have two ghosts one on top of the other, it will be only see the one like in the normal, like in the non-ghost world, you will see only the
you won't see two ghosts behind one another. You will just see the front one.
Oh, that's so cool. That's so nice.
But it's kind of expensive to do that. The performance of it was not good, and so we spent a long time digging into that. Like multiple of us, we got people external to the company to take a look at it. Professional graphics programmers took a look at it and had a stab. And there's been like 3 or 4 of us that have had input on this specific shader to get it sort of performant enough. Because, for example, on the Switch and the PS4, they're both very low-powered consoles. So the Ghost shader only does one blur pass to make it sort of blurry. And also, interestingly, I made it so that the ghosts render at a lower resolution than the screen resolution on the Switch and the PS4. The player does not notice this, but it means that rather than rendering them at such a high resolution, I'm
Yeah.
rendering them down really small, and then they just get upscaled,
Yes.
drawn big, and you don't really
And this
notice
is
it.
blur. This is blurred, so you won't see
Yeah,
this, right?
you're not going
Because
to
it's yeah,
necessarily notice because the edges are a bit blurry. So
yeah,
it's
yeah, yeah,
yeah,
yeah, yeah. It's expensive. Both transparency is expensive, but for example, blur, the Gaussian blur. There are a couple of techniques how to do it for the GPU to be effective, and if you don't follow them, you
we
can like even in a simple like blurring effect, you can mess up.
we blur in two directions. So we do a vertical blur
Yeah,
and then we do a horizontal blur. And if you do them both once, it looks fine, but it looks better if you do it around 4 times.
yeah.
But doing it 4 times is kind of expensive because each time you do a blur in a direction, that's a call to the graphics card, and you want to sort of do as few of them as possible.
Yeah, that's so cool. Nice. I did not use. I haven't used the scriptal render pipeline.
But this is how the outlines around the objects are drawn as well, because you the outlines need to show up over the top of everything, kind of, in some cases at least.
So that
Um,
you can see even
so
the
that you can
half
see
of the
them even
object
if
is
they're
yeah,
obscured. You want to
yeah,
see the outline. So for the outlines, we take the object's mesh. So we still draw the object with the standard camera, but then we take
yeah,
that object's mesh and we draw it in bright blue, and then we blur it about I think it's like 5 times with like quite a big blur factor to bring it out, and then we subtract the shape of the block from it. So we just get the bit that's blurred past the edges of the block, and then we draw that on the top of the screen. I think before we do the ghosts, so the ghosts show above the
yeah,
outlines, I think. But
yeah,
yeah,
yeah. And it's also interesting that if you start doing this and mess with the rendering order and rendering pipeline, then with each effect, like you mentioned, outline and ghost are two separate things. You need to think, okay, so we now need to determine the order. And if you get the third one, it's like additional thing. Like
yeah. But also you have to make sure that you don't mess up the ghost shader with the outline shader, because you're dealing with the graphics card.
yeah,
If you clear a texture, which you often do because you don't want to have like loads of textures living on the graphics card, I think you've got a limit of, is it 8? I'm not entirely sure. It's been a long time since I've
yeah,
done my graphics card theory, but there's a limit of how many textures buffers there are on a graphics card that Unity has access to. So if you clear the wrong one, um, you've lost your depth texture and ghosts stop working. So you want to be careful with how you do it. And
yeah,
because we had it so many times where I would touch the outline shader and then ghosts would go really weird.
yeah. And the ghosts go so this ghost shader, it use you use them both for the ghosts like people, and then for the prisms when you're controlling the prism, right? Or
No,
this is
so the prisms don't actually become ghosts. They're doing a whole different thing. They're using a shader graph shader, which is
okay,
the sort of visual scripting
yeah,
version of creating shaders, and they have a whole dissolve system on them that does something completely different
okay,
to make them sort of come in and out, because they're not really transparent per se. They're just they feel like they are because of the shade of blue that they go.
yeah, yeah,
But the player's hands and body is ghosts,
yeah,
um, which is annoying because it then means the ghost shader has to run all the time because the
yeah,
player's hands are pretty much always in view.
yeah, yeah. And then the path is also ghosty?
Well, no, so the path is actually a line renderer, which is
Okay.
a Unity thing that they've
Yeah.
provided, and we just give it a nice texture, and then we tell it to be a bit transparent,
Okay.
and then we've got a particle effect and that sits at the front of it, and basically as the particle effect gets thrown down the path that the soldiers would follow, it's actually a soldier that's just had its mesh turned off and has a particle effect in its place, and it just moves really fast down the path. And then the line renderer basically hangs about a bit, so that's why you get a line, because it just hangs about behind and just draws the line that is followed.
Yeah. Yeah.
And so
Did
there's a fine tuning of how high resolution your line renderer needs to be, how many points you give to the line renderer to draw it. Because if you give it too many, performance goes really bad. So
yeah.
on the Switch, the visualizer has less resolution than say on PC or in VR.
Yeah, and every time when you say, for example, that you do something differently on Switch, you do this through the like directives in code, like if platform this, do this, and you need to keep in
Most
mind
of the
that like
time, yeah. So
yeah,
you do if Nintendo Switch do this resolution, if this do something else. We have a whole platform system that lets code know without having to do if defs what platform it is. So we've got a platform system and a user system that sets up users when they log into the game, and then so they're not online users. It's just how you have to do it with platforms. You have a user that lets the platform know what platform it is, and then the platform can just be accessed, and you can just go if platform equals Xbox, do this. If platform equals PlayStation, do this, and you can do switch statements. So you can have if PS4 or Switch, do this, and it means you don't have to have a bunch of if defs,
yeah,
which is nice because then it means that if you've got errors in your code, you can sort of see it without having to do a
yeah,
build. Because with the if defs, you either need to switch Unity engine copy to
yes,
your whatever copy of the project you've got.
yeah,
Um,
yeah. Because
whereas,
idea of the if defs is that they will actually be cut out of the
yeah,
and that the code will not be there for the platform. But then you need to be like go outside of your coding part, like outside of coding system compilation, and switch what is the platform, right?
yeah,
So
and then it needs to recompile your whole code
yes,
project, which
yeah,
our project's pretty big now, so that can take a few minutes. Which if you're just writing a very quick bit of code,
yeah,
you don't want like a saving system. You just kind of want to see a lot of it just there and then and see what say file paths it's using or whatever. So for small bits of code, we don't bother with the if defs, but
yeah,
for bigger bits and with say VR code, we do put big if defs around it because you can't. Some of the platforms don't support VR, so you can't do you can't have VR code on a
yeah,
platform that doesn't support VR because it will just crash and burn.
yeah, yeah. So tell me, what is the suite of tools that you needed to develop for the game?
So we got all the stuff to do with the pathing system that we
Yeah,
developed, which is sort of a tool, sort of a feature,
yeah,
sort of together. Um, we've got we've then got this whole thing that links into the pathing system and the blocks called with the path change elements, which basically lets you tick a box, and in the Unity editor you can draw these bounding boxes, which are just cubes that surround things. So the path change elements have them, and the segments that the soldiers walk along have them, so that you can see what is interacting with what. And then if you say move a block to block the path, you can then see that that block is blocking that segment, and then that then feeds into the whole pathing system and how it works to know that segment's no good anymore, it needs to be regenerated. So we had to write a whole tool for that so we could see what was going on.
yeah.
Uh, what else have we got? We have, so in the later stages of the game, we have a whole electricity system where you have these generator machines that produce electricity, and then we have switches and machines that get powered by these electricity things. We've got power cables that light up on the wall. And so there was this whole tool that we ended up having to write that lets you visualize what so if you click on a generator and you say, show me what this generator powers, it will draw debug lines across the scene and spawn big balls on top of the objects that it is powering, because we had lots of problems where things weren't getting powered up when we thought they should, and it was turning out that like down the line they weren't actually hooked up properly. But finding that when you've got, say, I don't know, 20 machines in a 20 electrical objects in a room that all need to be hooked up correct, you get a bit confused. Whereas with this, you could just hit a button and it would sort of show you. It's not the best tool in the world, but we didn't have particularly long to throw it together. We also have these what they called vacuum tubes in these basement levels as well, where the soldiers sort of walk in and they get sucked up, and it's sort of like the pipes out of Futurama, where they get blown along by air and spat out at another location. But for those, we need the pipes to snap together to be in line with one another, which can be kind of awkward when you set up the bases in the entrances and exits, and then you need to connect them to one another. So what we have is, when you move in a section of pipe close enough, we've got these gizmos that are only visible in editor that are like these wireframe balls, and they're red normally, but when they are intersecting one another they go green, which then means you can hit a button on that object and it will snap it to then be stuck together. Sort of, I guess, like in a game like City Skylines, when you bring a building close to a road and then it snaps onto the road. But we had to code that just for ourselves. And so then to create the whole pipes, you then drag them together and you hit the button and then they snap into place and then register themselves with the whole vac tube system.
Okay. Am I getting this right, that most of the tools were made for help with the debugging and knowing what's going on?
So yeah, there was, we've got a lot of tools for helping with the debugging. That was the bulk of it, was the pathing system stuff.
Yeah.
But then the electrical one and the vacuum tube one was more for the designers to be able to sort of set up the stuff in the level without having to be exactly precise and do a bunch of extra work, when really you just want to drag and drop and make it happen. Because we also we've got the spawner box that spawns soldiers, but that's not very good in editor because you don't want to have to press play every time. So we've got this box called the Pathing System Demoer, which is a terrible name, but it's a box that when you click on it, you can just press a button that says tick, and it will draw out path steps out of it to show you where a soldier would walk. And so, say a designer is setting up a balloon jump that needs to land on another table, they would have to tweak the values of the floatiness of the balloon. And to do that and then press play and get the soldiers over to it to then do the jump would be a nightmare. So we've got this thing in editor where they can just press tick a few times and they'll see the path grow out, visualize in editor. There's no soldiers on it. It just does the movement path. And that means that they can see their sort of whether they're making it to where they need to go without having to actually play the game.
Okay. And because your levels are very precise and you can't really just you probably have to drag and drop and set the proper places as a designer in just a level. Like, there's no getting around with making a tool that would do it for yourself. You don't have a grid that will be like, move it one block somewhere else.
Yeah, we always talked about creating a level designing tool, that would sort of like snap things together and make them align, but we just never had the chance. And by the time that we were at the point where maybe we could have done it, most of the game was already designed. So
Yeah.
it, yeah, it's it, it's frustrating because those sorts of things probably would have made the designers' lives a lot easier. They would have
Oh,
spent a lot
definitely.
of time nudging objects ever so slightly. Because also it affects the art department as well because they're decorating the levels, but they need to like make sure that they don't put like a spanner on a table in the path of where a soldier's going to walk, because if they hit the spanner, they might bounce off and go in a different direction. So you you need to be able to test this stuff quite easily without having to play the game every single time.
Yeah. But have you seen the possibility to create a level designer tool, even though you're not like on a grid based, so that you'll be just like it will be like a moving objects with snapping? How do you see this?
I mean, it would have been a nice thing to do, but
Okay.
I think it's one of those things that like it would have always been a nice thing to do, and we've spoken about it a fair bit. But when we're having to create all these other features all the time and
Yeah.
bug fix everything, it's like when the designers can just nudge things back. Because we also, in order to sort of alleviate some of the pain, we have these trigger boxes things that you can drag in that are called funnels, which when the soldiers walk through them, it will funnel them to then be
Yeah.
going in a specific place. So if things aren't quite perfectly lined up, a designer can just slap a funnel in and they will all end up
Yeah.
in line with the thing they're going to walk into ultimately. So it sort of gets us around having to be so precise with the level designs.
Yeah. Okay. And how many level designers plus coders were interacting with the same scene files and project?
Well, like at any one time, we only have one designer in a level, and we have we have a spreadsheet because we're using Git. We can't lock files, which you
Yeah.
can do in Perforce.
Yeah.
So we've just got a spreadsheet with every single level in the game, and in some cases, in a lot of cases actually, we have prefabs within the levels, which are like a collection of objects. And so we have a lighting prefab that contains all of the lights and the lighting system, and then we have a gameplay one and an environment one. And so uh, different designers and people in the company and artists and VFX people and whoever can lock the individual prefabs to say, I'm using this,
Okay.
so that hopefully no one else touches it.
Yeah.
But if someone doesn't think to check the spreadsheet, they may end up doing like a day's work, and then it turns out someone's had that for a week, and so
Yeah.
they're going to have to throw their work away or redo it. And but for the most part, it works. But like I mean, so up the game up until about level 20, I believe, was originally created. It was worked on for like 2 years. Um, and I think the team was around like 6 or 7 people at that point. Um, and it was shelved for a few years. It was released as early access, but then not really touched for a couple of years. And then I joined the company, and sort of my first job was sort of resurrecting the project and bringing it back,
Yeah.
as we had got a publisher that was interested. So sort of brought it back up, got it running. But like half of the people that originally worked on it weren't at the company anymore. They had moved on,
Yeah. Okay.
gone elsewhere, done whatever they do. So a lot of those people weren't around anymore. So we then ended up with a new group of people. Um, and then another project at the company ended, and so a bunch of new people that had been working on that project came and joined. And then over the time, people have left, new people have joined. And so there's sort of been 3 separate teams of people that have worked on the one
Yeah.
game, with only a few people that have sort of hung about for the full, I guess, 8 years or six years, I guess, of it.
Okay.
Um, and so, like, I mean, each individual level, there's maybe been one, two, maybe 6 designers. I've
Okay.
touched most of the levels. We tried to make it so that like a designer would own a level and that would be their level, and so if anything needed tweaking with it, they would go back to it. But inevitably,
Yeah, it didn't work out.
everyone ends up touching everything,
Yeah.
and things always end up getting tweaked. And then, like code wise, there has been 2, 3, 4, 5, 6. I want to say like 10 or 12 coders have
Oh,
touched the project over the time, and that's like internally. Then we've had um, external people as well
yeah,
come
yeah,
in
yeah.
and help when we've needed it. So it's been quite a few people,
Okay.
and sometimes you do have the problem where you're looking at a system and the person that wrote the system hasn't been at the company for like 2 or 3 years, and so you can't exactly just go ringing them up and go, "Help,
Yeah.
how?" It's
Please.
yeah, you just have to sort of grit your teeth and just figure it out, and
Yeah.
yeah.
Okay. Okay, we've been going on for like 90 minutes, and I think that's we're nearing the end. So tell me, what lessons have you learned while working on Teen Hearts? How?
I think probably if you feel like a system needs rewriting, do it when you start feeling like it needs rewriting. Don't put it off. Because if you put it off, it'll be too late, and then you have to live with it. And so many things in this game like were written the first time, and then it's just been added to and changed. Whereas if you've written it the first time and things have started changing, go right. I'm gonna take a week or two to rewrite the system properly. Now that I know what it's actually going to be used for, probably going to have a much nicer time when you're bug fixing later on, because it'll make sense. I think the other thing is like documentation. Document everything,
Oh, really?
because we've got quite a big documentation like wiki thing, but so many things aren't documented. So much code isn't commented, and so like sometimes when you're just doing something quick that you think is, oh, that's a tiny feature, no one's ever going to touch this again. It's definitely going to be touched again, and it's probably going to like be you, and you're going to hate yourself because you don't know how it works anymore. It,
Okay.
but I think those are the two biggest things, because you just end up forgetting how things work, and then trying to patch
Yeah.
stuff into old systems that you don't know how they work
Yeah.
necessarily, because they're so big that like we've got systems that are like, well, we've got files that are over 10,000 lines long,
Yeah.
just like single classes, and so you're never going to really understand the full thing unless you wrote it yourself. And when there's not great comments and not great documentation,
Yeah.
it
And
really,
also the project span for a couple of years. Like,
yeah, it is.
yeah.
I think, yeah, projects of a shorter length would be nicer to work on. Not sure I'd want to do such a long project that's been across so many Unity versions again.
Oh, yeah.
It's just
Oh, yeah.
yeah, just pick one version, pick less than 7 platforms maybe, then just focus on one at a time rather than trying to do
Yeah.
everything at once.
Yeah. And documentation wise, have you done documentation like outside of code comments to like have?
We don't use like Doxygen or anything like that. We do it all separately, because the main documentation that we're missing is like for just like the general structure of code and like the flow. So
Okay.
like rather than specific like calls to functions,
Yeah.
it's more the like, oh, the the way that we save the number of soldiers that you've saved in a level goes through this system, and this system then
Yeah.
calls the save system and saves it here. It's
Yeah. Yeah.
it's more the flow of things that gets lost rather than the
The details.
individual functions,
Yeah.
because the code's written fairly well that you can read it and get what it's saying. But like when you're jumping between 10 separate classes, and
Yeah.
you just sort of get lost.
Yeah. And it's, yeah, because when you're working on a like subsystem here, then you can document it. But you need to take a step back at some point and connect all those systems that reuse each other. And there's no like a natural place for writing documentation for like higher level, right? You need to really step back and dedicate some time to it.
Yeah. And I think the other thing is documentation for like the designers to use, because when you create a system, you've made it yourself, you know how it works. But when a designer then needs to set it up on an object or put it into a level, it, you end up sat there describing it to them, and it, nothing's going to be as good as like a proper, like, well-written bit of documentation that's going to explain exactly how it should be set up and what it should do. But like sometimes you don't get that luxury because the designers need to start implementing it in a level before you've finished coding it, and so it's just cat and mouse, just constantly chasing each other. Just yeah.
Okay. Okay, Toby, it was a really nice talk, nice conversation. Thank you so much for sharing all the details with me, with the code and how Tin Hearts work.
I know it was great.
Thank you so much. Take care.